We just did something most people only argue about online. We ran the same engine on 3 different oil weights for thousands of miles each, tore every single one apart, and measured the wear on every critical component with precision tools. Why this matters? Oil weight is one of those topics where everyone has an opinion, but nobody has actual data. Go into any car forum, and you'll see people swearing that thinner oils like 0W-20 give better fuel economy. Others claim thicker oils like 5W-40 provide superior protection. And most people just pour in whatever their manual says without a second thought. We wanted to know the truth. So we bought 3 identical 4-cylinder engines, ran each one on a different oil weight under identical conditions, then tore them down to see exactly what happened inside. Here's why this matters more than you think. Your engine's entire life depends on getting this right. Use oil that's too thin, and you might not get enough protection between metal parts, especially when the engine is hot and working hard. Use oil that's too thick, and it might not flow properly during cold starts, which is when most engine wear actually happens. Get it wrong either way, and you could be staring at thousands of dollars in repairs or a completely dead engine. Car manufacturers spend millions testing to figure out the exact oil weight that works best. They put that recommendation in your owner's manual for a reason. But some people think manufacturers only recommend thinner oils to achieve better fuel economy numbers for government testing, not because it's genuinely better for your engine. Others believe thicker oil is always superior because it creates a thicker protective film between metal parts. So we settled this once and for all with a real test using real engines under real conditions. The test setup. We used 3 identical engines from the same car model. Each had about 50,000 miles before we started, so they were broken in but not worn out. We rebuilt all 3 to identical specifications, installed them in test rigs, and prepared to run them hard. The 3 oils were 0W-20, which most modern cars recommend, 5W-30, the classic weight that's been the standard for decades, and 5W-40, what many European performance cars use. All 3 were high-quality, full synthetic oils from the same brand. Same additives, same base oil quality. The only difference was viscosity. We ran each engine through the exact same test cycle. Cold starts, highway cruising, hard acceleration, idling, everything a normal engine experiences. Each engine ran for 5,000 miles on its assigned oil weight. We monitored oil temperature, oil pressure, engine temperature, and numerous other data points throughout. Then we drained the oil, completely tore down each engine, and measured wear on critical components. We focused on cylinder walls, piston rings, crankshaft bearings, camshaft lobes, and valve train components. These parts wear out first and are the best indicators of whether oil is doing its job. We used precision measuring tools to detect wear down to thousandths of a millimeter. This wasn't visual inspection, this was scientific measurement. The 0W-20 results. Let's start with the 0W-20 engine, the manufacturer's recommendation for this motor. The 0W means it flows like a zero-weight oil when cold, and the 20 means it has the viscosity of a 20-weight oil when hot. This is pretty thin compared to what people ran decades ago. During testing, the 0W-20 engine showed excellent oil pressure at startup. The thin viscosity meant the oil pump could circulate it immediately, even when the engine was dead cold. This is critical because most engine wear happens in the first few seconds after you start your car, before oil has reached all components. The faster the oil gets where it needs to go, the better. Oil temperature stayed relatively low throughout testing, which makes sense because thinner oil creates less friction. Lower friction means less heat generation. Oil pressure while running at operating temperature was on the lower end of normal range, which is expected with thinner oil. Not dangerously low, but definitely not high either. When we tore down the 0W-20 engine, here's what we found. The cylinder walls showed minimal wear. We're talking less than 1/1000th of a millimeter of material removed after 5,000 miles. That's excellent. The piston rings showed no significant wear either. Ring gaps hadn't increased, ring faces looked good. Everything was within spec. The 5W-40 shock. Then we have the 5W-40 engine, and this is where things got really interesting. The 5W-40 oil is significantly thicker when hot compared to the other two. This is the kind of oil you see in high-performance engines, turbo engines, and many European cars. The theory is that extra thickness provides better protection under extreme conditions. During testing, the 5W-40 engine had the slowest oil pressure buildup on cold starts. It took a few seconds longer than even the 5W-30 to get full oil pressure, which makes sense because the oil is thicker and harder to pump when cold. Once warm, oil pressure was substantially higher than both other engines, 10 to 15 psi higher at idle, and 20 to 30 psi higher under load. Oil temperature ran about 10 to 15 degrees hotter than the 0W-20 engine. The extra friction from thicker oil was definitely generating more heat. The engine ran fine throughout testing, no issues, but you could tell it was working harder to move that thicker oil around. The teardown is where the 5W-40 engine shocked us. The cylinder walls showed more wear than the other two engines. We measured about 2 to 3/1000ths of a millimeter of wear, which is 2 to 3 times what we saw on the other engines. The wear pattern was more pronounced and easier to see visually. The piston rings on the 5W-40 engine showed signs of working harder. Ring faces had visible wear marks, and ring gaps had increased slightly. Not enough to cause problems yet, but definitely more than the other engines. This suggests the thicker oil was actually making it harder for the rings to do their job properly. Here's where it gets really interesting. The crankshaft bearings showed less wear than any of the other engines. The wear pattern was barely visible, and bearing clearances had barely changed at all. The thick oil film was clearly protecting these components extremely well. But the camshaft lobes showed more wear than the other engines. Not a lot, but measurable. The valve train components also showed slightly more wear. Why this happens? So what's going on? Why would thicker oil protect the bearings better, but cause more wear on the cylinders and valve train? The answer comes down to oil flow and how different engine components work. Bearings are designed to have a thick film of oil between metal surfaces at all times. Thicker oil creates a thicker film, which provides better protection. Bearings in an engine are under constant pressure and load, so that thick oil film is beneficial. That's why the 5W-40 engine had such minimal bearing wear. But cylinder walls and piston rings work differently. The rings need to slide up and down the cylinder wall millions of times, and they need to seal against the cylinder wall to prevent combustion gases from leaking past them. If the oil is too thick, it can actually interfere with the ring's ability to seal properly. The rings have to work harder to push through the thicker oil, which causes more wear on both the rings and the cylinder walls. The valve train sees similar issues. The camshaft lobes and lifters need oil to flow quickly to prevent metal-on-metal contact, especially during cold starts and high RPM operation. Thicker oil takes longer to get where it needs to go, which can lead to momentary contact and increased wear. This is why engine manufacturers spend so much time and money figuring out the exact oil weight for each engine. It's not just about fuel economy, though that is part of it. It's about balancing protection for all the different components in the engine, each of which has different requirements. The 0W-20 recommendation for modern engines makes sense when you understand this. Modern engines have tighter tolerances, better manufacturing, and improved materials compared to older engines. They're designed to work with thinner oils that flow better and create less friction. Using thicker oil doesn't necessarily provide better protection, and in some cases, it can actually cause more wear in certain areas. So, here's what you need to know. Use the oil weight your manufacturer recommends. They tested it extensively, and they know what works best for your specific engine. If you want to go one grade thicker, like using 5W-30 instead of 0W-20, you're probably fine, and you might even see a tiny benefit in bearing protection. But don't go crazy with thick oil thinking it'll make your engine last forever. Our test proved that thicker isn't always better. Oil quality matters more than oil weight. Buy good synthetic oil from a reputable brand and change it at recommended intervals. That's way more important than, but don't go too far, or you'll start seeing real problems. If you want to see more tests like this, where we actually measure results, instead of just guessing, hit subscribe right now.